File input, output, or I/O is crucial in programming, enabling applications to persistently store and retrieve data from the file system. This capability is essential for tasks like saving user preferences, logging events, or managing complex data. In C#, three core classes manage file operations: FileStream for raw byte-level access, StreamWriter for writing text, and StreamReader for reading text. FileStream forms the foundation, while StreamWriter efficiently writes text, and StreamReader simplifies reading text content. Let's begin with StreamWriter, the simplest way to write text to a file in C#. It automatically handles character encoding and efficient data buffering, making text output much easier for developers. To create a new text file, instantiate StreamWriter with the desired file path. If the file exists, it will be overwritten by default. This crucial behavior truncates existing contents, replacing them entirely with new data. The WriteLine method allows you to add lines of text, automatically appending a new line character after each entry. This convenient feature ensures subsequent text starts on a fresh line, simplifying text formatting. A critical best practice is to always use the using statement with StreamWriter. This ensures the stream is properly closed and disposed of, even if errors occur, preventing resource leaks and ensuring data integrity. Now, let's explore StreamReader for reading text from files. You open a file by creating a StreamReader instance with its path. This class efficiently retrieves text data from files, acting as the counterpart to StreamWriter. You can read the entire file content into a single string using the read-to-end method. This method reads all characters from the current position to the end, returning them as one comprehensive string, ideal for smaller files or configuration data. For line-by-line processing, use a while loop with the readLine method. This is ideal for structured data or log files, reading one complete line of text at a time, allowing systematic iteration. ReadLine returns null when it reaches the end of the file, providing a convenient condition to terminate your loop. This prevents reading beyond the file's content, effectively managing file boundaries and preventing errors. StreamWriter and StreamReader are built upon FileStream, which offers a lower-level, byte-oriented approach to file access. FileStream directly interacts with the operating system's file services, meaning text operations translate into byte operations. When creating a file stream, you specify file mode, which dictates how the operating system opens the file. This crucial enumeration controls the file's initial state, including whether to create, open, or append, providing fine-grained control. File mode. Create makes a new file or overwrites an existing one. File mode. Open opens an existing file. File mode. Append opens a file and moves the cursor to the end, allowing new data to be added without affecting previous content. These options provide precise control. You also specify file access, defining whether you'll read, write, or both. This enumeration determines the type of operations allowed, ensuring proper permissions and preventing unintended access. It's a critical parameter for controlled file interaction. Here's how to use FileStream directly, then wrap it with StreamWriter to write text, demonstrating their relationship. This shows how StreamWriter leverages FileStream's byte-level capabilities for text-oriented writing, offering a powerful way to manage file content. This code creates a file stream, then passes it to a StreamWriter, allowing text operations on the byte stream. This sequence establishes a direct byte-level connection, enabling convenient text-based operations like WriteLine on the underlying stream. To append text without overwriting, use the StreamWriter constructor with append true. This instructs the StreamWriter to open the file and position itself at the end, ready to add new data, preserving existing content. Alternatively, you can achieve appending by using file mode, append directly with FileStream. This mode ensures that if the file exists, new data will be written to the end, preserving all existing content. This is crucial for log files or data accumulation. In summary, FileStream provides foundational byte-level access, while StreamWriter and StreamReader offer convenient text-oriented operations built upon it. They abstract away byte manipulation complexities, making it easier to work with text data. Always remember the golden rule. Use using blocks for all I/O streams to prevent resource leaks and ensure proper disposal. This practice is vital for FileStream, StreamWriter, and Stream Reader, guaranteeing resource release even with errors. For robust applications, incorporate exception handling with try-catch blocks to manage potential issues like file not found exception or I/O exception. This allows graceful recovery from problems such as missing files or permission issues, ensuring your application remains stable. Mastering these C# classes will significantly enhance your ability to interact with the file system effectively. This knowledge empowers you to build applications that reliably store, retrieve, and manage data, a core requirement for real-world software solutions.